Given that x does not equal 0, simplify the expression 12x over 3x. Okay, well, the 12 and the 3 give you a 4, and the x squared and the x just leave you with x. So 4x would be the simplified expression. What is the value of the expression when x is 5? So instead of plugging it in here, you can just plug it in this guy. So it'd be just 4 times 5, which is 20. Given that n is 2m, what is the value of this expression? So we can simplify it first. The 8 over 3, the m's cancel, and then I think you just get an n at the end, like that, just like that. And then, hold on, I think there's an m also. Yeah, there's going to be an m there. Okay. So then they're telling me that n is 2m, so I got to substitute that in. So that means 8 times 2 times m over 3m. So that's going to be 16 over 3. And I believe the m's will cancel. And I think that's it. If the m's cancel, the only thing left is 16 over 3. And then d, we have q is 6, and they want you to figure out all the possible values of p for which that inequality is true. Okay, so let's see. We have 3 is less than or equal to 8. P squared q all over 5 p q squared less than 4. Okay, so let's see here. Let's see what we can eliminate first. The 8 over 5, I don't think we can do anything there. The p can be eliminated, so there's a p on top, and then the q can be eliminated, so there's just a q on the bottom right there. Okay, now let's substitute our value of q equals 6. So if q equals 6, we're going to have this 8 over 5 times 6, so 8 over 30 times p. And that's going to have this 4 and 3. And then multiply everything by 30 over 8. So if I multiply everything by 30 over 8, I'll just get rid of that number. So this will be what? 90 over 8 is less than or equal to p is less than, what's that, 120 over 8? Yeah. Okay. And let's see here. So when you turn those into numbers, you'll get 11.25 and 15. So that's basically means that p is either 12, 13, 14, or 15, because p is an integer. Here are 2 facts about circles. If points A, B, C lie on a circle so that ABC is 90 degrees, then AC is the diameter of the circle. This means that figure 1, AC is the diameter of the circle. If points D, E, F lie on a circle so that EF is a diameter, then angle EDF is 90. This means that in figure 2, EDF is 90 degrees. In figure 1 above, AB is 8, BC is 15. What is the length of AC? So this is basically another Pythagorean relationship, 8, 15. So AC squared is 8 squared plus 15 squared, and anybody can do that. When you do this, you get AC equal to 17. Part B, in figure 2, D is 24, the radius is 13. What is the length of DF? So the radius is 13, so that means EF, which is the diameter, would be 26. And they told me that DE is 24, and they want me to figure out DF. So we got Pythagoras again, DF squared plus 24 squared is 26 squared. And when you solve that, you get DF equal to 10. And C says, in figure 3, points PQRS are on a circle with center O. Also, SQ is the diameter of the circle, and O is joined to R. If SP is equal to PQ, angle RQP is 80, determine the measure of angle ROQ and measure RSQ. Okay, so we got to do something known as angle chasing. Some of you are familiar with that. It's not that bad, not that difficult. Okay, so let's see here. Since SQ is the diameter, right? Yeah, SQ is the diameter. We can conclude that that is 90 degrees. And therefore, since this is labeled as the same as that, these two angles will be the same. So this will be 45, and this will be 45. So that's pretty straightforward. And then what else can we do here? O to Q is a radius, a radii or radius, whatever. OR is also radius, so that means we got another situation where we have an isosceles triangle. Okay, and then we also have a similar isosceles triangle situation with that guy. So, well, you get the point. They're both isosceles. So we know for a fact that RQP is 80 because that's given in the question. So if RQP is 80, then if you subtract 45 from it, then this angle's got to be 35, right? Because 35 plus 45 is 80, which is RQP. And then since that's isosceles, that's 35. And then you can easily figure out this angle in here. It would be 110, I believe, because the sum of the angles have to be 180. And then we can make this a little bit larger. And then same thing, this is going to be 70 since those two angles have to add up to 180, the 70 plus 110. And then this is isosceles again, so those two angles, this guy and this guy, have to be the same. So that's going to be, both of them will be 55. And that's essentially just angle chasing. And what do they want here? They want ROQ and RSQ. ROQ and RSQ, those angles. Okay, ROQ, I believe, was 110. And RSQ is 55. And that's it. Cylinder A has a radius of 12 and height 25. Cylinder B has radius 9 and height h. Cylinder is then filled with water to a depth of 19. Cylinder B is empty. Cylinder B is lowered to the bottom of cylinder A as shown depending on the value of h. Some water may spill out of cylinder A onto the ground, or some water may pour into cylinder B, or one and then two. The walls and the bases of the two cylinders are thin enough so that their width can be ignored. Suppose that h is 30. What is the volume of the water that spills out of cylinder A onto the ground? All right, so I'm assuming you understood all this. So let's start solving the question because I'm going to need a lot of space. Okay, so let's draw a few diagrams to help illustrate what actually is happening. So first you've got this cylinder that's sitting there, and then you got this water, right? So you got this big, well, it's taller, and initially we just place it so that it just touches the water. So nothing's happened so far. And then what we do is we keep pushing that cylinder deeper down into the water. So that what that does is it makes the water level rise on the sides there. See what's happened? Okay, then eventually what will happen is you will get a situation where the water level rises all the way to the top. Nothing has spilled out yet, but this is part of the process. So here it's basically just been placed so that it touches the water. Here it's been placed inside the water so that the water level has risen a little bit on the sides, see? And here it's been pushed down so deep so that the water is all the way at the top of the cylinder. Then what happens is you have a scenario where the water starts to pour out. So at this point, it's definitely filled, but then now water's coming out. And then finally, you have a scenario where, running out of space, it's sitting at the very bottom, and then the water has poured out as much as it can. All right, so now keep in mind that this has a height of 30, and our cylinder A had a height of 25, I believe. So that is very important. So basically what we're doing is we're trying to figure out how much water came out. So a couple steps we need to take. The first is we need to calculate how much was in the how much water was in there initially, and that volume is going to be pi r squared times height, and in this case the radius I believe is 12 for cylinder A, and the height is 20. The height is 19. The height of the full tube is 25, but this height is 19. Not drawn to scale, of course, but that's okay. So that's 2736 pi is how much water was in there initially. Now, when all this is said and done, this is how much water is remaining. So we would need to figure out how much water is remaining. Now, how do we figure that out? That is basically going to be the amount of water, the amount of the total volume minus the volume that cylinder B occupies. So the total volume would be pi, the total radius I believe is 12 squared times 25, which is the total height from top to bottom. And then minus that, what is occupied by that cylinder A, which I think is hollow. So that's going to be minus pi, radius is 9, right? Yeah, and 9 squared, and then 25, because the height is also 25. So that is 3,600 pi minus 2025 pi, and that gives me 1575 pi. So that's how much is remaining, and this is how much was in the beginning. So to find out how much spilled out, we would just take how much was in the beginning and how much is remaining, and that will give you how much spilled out, and that is 1161 pi. That's how much volume of water that spilled out of cylinder A onto the ground. Suppose that height is 20. Determine the volume of water that spills out of cylinder A onto the ground and the depth of the water in cylinder B when it is on the bottom of cylinder A. Again, I'm going to draw some diagrams to illustrate what is occurring. So first you've got this water in there, and we're going to have the cylinder sort of placed inside so it just touches, so nothing's happened yet. Then the next is when we push the cylinder a little bit further down, right, and the water starts to rise, and I guess it just starts to rise, and then eventually you're going to have a scenario where we have it like this, where it goes a little bit further down, but then the water is at the very top, very similar to the previous question. And then eventually you're going to have a scenario where the entire the tube is on the ground. But this is different because this time the height is 20 of cylinder B. So that means it's going to be inside entirely, like that. And because of that, water is going to start pouring in. You see what's happening here? It's a little bit different than before, because before the height was 30, so no water would ever pour into B. But now, because the height is 20, water is going to pour into B. So we're going to have to make a couple diagrams, and I'll just make that one, and then I'll make the next one, which is showing what exactly happens. You're going to have some water in there, and this, I assume the water level here would be like that. Okay. All right, so you got it? Okay, so let's talk about this. We need to figure out first how much water was there in the beginning. Well, that's not a problem. It's pi r squared. R was 12, and the height was 19, just like before. So this is 2736 pi. Okay. So now we have to figure out, what do we have to figure out? How much water is in here, right? Okay, that's our ultimate goal. Okay, well, one thing is for sure is that when we continue to push this water down, see, in this diagram, nothing's happened, and nothing has come out of the tube of cylinder A, and nothing has gone into cylinder B. But when you actually get to here, nothing has come out of cylinder A yet. But once you go past that stage, water will start to come out. And how much comes out is how much is displaced right here. So that's a very important amount that needs to be calculated. So that is going to be pi, that radius is 9, and what is the height there? 9 squared. The height is 5, right? Yeah, I believe the height is 5, because if this was drawn to scale, this would not be there, right? because you're comparing 25 with 20. Yeah. So this would be 5. So that's 5. And therefore, that's going to be 405. Okay, so 405 is part of the water that will eventually end up here. Correct? Because the water is not going to pour out, it's going to pour into B once we go to this stage. And in addition to this 405, these guys are also going to pour into B. Correct? So we got to figure that out. So how do we figure that out? That is going to be these guys here, this guy and this guy. I guess we have to figure out the total, which would be pi 12 squared times 5, because this is going to have a height of 5. These guys, and then we have to subtract the inner tube, which would be pi 9 squared times 5. Yeah, very similar to the previous question. And then this is 315 pi. So this and this is what ends up going into that. So 315 plus 45 is 720. So it's 720 pi is the volume of water that goes into cylinder B. Now, what are they asking? They want the depth of water. Okay, so they want the height. They want to know what is this height top to bottom. Okay, well, we can just put in that formula, pi r squared times height. The r for cylinder B, I believe, was 9. So that's 9 squared times height is 720. The pi's cancel. So h is just going to be 720 over 81. And 720 over 81, I believe, is, in lowest terms, is just 80 over 9. So that solves part B. Determine the range of values of H so that when cylinder B is on the bottom of cylinder A, there is some water in cylinder B, but it is not full. Okay, so again, let's draw some diagrams here. So this is our first diagram, and this is when it's just touching, and then we got another diagram here when we start pushing it down and the water level starts coming up to the top. And then eventually we have a scenario where it's going to be all the way on the bottom and like this. And we'll discuss these. So first, let's make some, let's label some stuff here. So this height from here to here, I'll just call H. Well, that's what they're calling it. And then the height of the cylinder A was 25, right? So I'll call that 25, and this height I'll call Y, the height of the water. And therefore, this distance there is going to be 25 minus Y. Okay. Okay, that's a pretty good start. And then, let me think about this here. So we need to figure out the volume of the water first. So let's do that. So let's use this diagram here. So this is Y. From here to here is 25 minus Y. And the water is basically all this. This is all the water. Okay, so volume of water. First, we'll figure out this container, that part, I guess. And that's pretty straightforward. That's just pi r is 12 squared, and then the height is Y. And then we got to figure out these guys, this one and this one. So that's a little bit different. That's going to be involving, very similar to before, we have to subtract first the full volume of the container, which would be pi 12 squared, and then 25 minus Y for the height. But then we have to subtract from that the inner tube, inner cylinder, because that displaces the volume. So that would be 9 squared times 25 minus Y is the height. Okay, so let's simplify this now. So this will be 144Y, and this is pi 25 minus Y, and then 144 minus 81, which I believe is 63. And then this is 144 pi Y, And then this is going to be 1575 pi minus 63y pi. And then this is going to be 81 pi y plus 1575 pi. Okay, so that's about as far as I can go there for simplifying this equation. Okay, so the water to spill into B, so let me write this down. For water to spill into cylinder B, the height has to be less than 25. Because if the height is greater than 25, then you're going to have a scenario like the very first question when the height is 30. No water will ever spill into B. So that's the first conclusion that I make. And then I have to eventually figure out what the height has to be greater than. Okay. So from part B of this question, actually, we know that the volume that spills into B is as follows. It is, first you'll take the volume of the cylinder. So that's going to be pi 9 squared, and then we're using 25 minus h. So for example, we've got a scenario. Let's say I need to draw a diagram here. We've got a scenario where it's been placed here, and this is h from there to there, and then that distance is 25 minus h. So that's the diagram. So it's going to be 25 minus h as the height. And then we have to add to that the amount that so I think I got to look at this diagram now. So it's at the very bottom. So the amount that was there, these two guys, that amount that was there, that's how much is also going to spill. So this amount that is going to be eventually displaced by cylinder B, and then these amounts that are eventually going to fall into B. So this amount we got is this right here, and then these two amounts, we did this before, it's pi 12 squared, and then what is the height here? 25 minus h, right? Yeah, 25 minus h. And then minus, of course, the inner cylinder. Yeah. So that one part leads into the other. So let's simplify this now. So this is going to be 144. Oh, sorry. Is it 144? Let's see here. Yeah, I believe so, because I think this cancels that. Yeah, so the only thing left is just this. So it's 144 pi times 25 minus h. Okay. And then to figure out the height, we just have to compare it to pi r squared. We'll just call it d, because I don't want to call it h, because it's going to become confusing. Okay. And this r, I believe, is 9. So this is going to be just pi 9 squared times d. And then if we expand this is going to be 3600 pi minus 144 pi h. And get rid of the pi's, and we get 3600 minus 144 h, and divide through by that 81, and that'll give me d. And I think we're getting close here. So we can divide through by 9. That'll be 400 minus 16h over 9. And then the diameter, the distance of the water from top to bottom, that's got to be less than h. So that means that 400 minus 16h over 9 has to be less than h, right? So then if we do this will be 400 minus 16h is less than 9h. So 400 is less than 25h, and therefore h is less is greater than 16. So that's my next finding. And if you remember, I had made that conclusion. So if you combine those, that means h is greater than 16 but less than 25. And that answers the question. For each positive integer k, we define ck to be the number of ways in which k can be written as the sum of one or more consecutive positive integers. For example, C21 is 4 because 21 can be written as 21, 10 plus 11, 6 plus 7 plus 8, and 1 plus 2 plus 3 plus 4 plus 5 plus 6. There are no other lists of one or more consecutive positive integers whose sum is 21. What is the value of C45? Okay, so for C45, we have to go through this. So C45, okay, what is the story here? Can we write 45 as the sum of one or more consecutive integers? Well, we can write it as the sum of one consecutive integer, that's just 45. For two consecutive integers, that would mean x plus 1 is 45. And if we do this, we get 2x is 44, and therefore x is 22. So that would mean our next list is 22 plus 23. That's a way of writing 45 as the sum of two consecutive integers. What about three consecutive integers? So that would be x plus 1 plus x plus 2 is 45. When you solve for this, you get x equal to 14. So that would mean this would be 14 plus 15 plus 16. You guys get the idea. And then you keep going. So how about four consecutive integers? That would mean x plus 1 plus x plus 2 plus x plus 4, x plus 3 is 45. So when you solve this, you get x equal to 9.75. So that doesn't work because x has to be an integer. And you just keep going like this. And you'll get eventually that you have this one. It's the same process. I'll let you do it. And you'll eventually get these three that I just got. You'll get one that works for when x is when we have 5 consecutive integers, so 7 plus 8 plus 9 plus 10 plus 11. Then you'll have one with 6 consecutive integers, 5 plus 6 plus 7 plus 8 plus 9 plus 10. And then I believe you have the last one, which is 6 consecutive integers, which is 1 plus 2 plus 3. 9 consecutive integers all the way to 9. And eventually you'll get to a point where when you solve for x, it's less than 1, and that's when you've completed it. So we have 1, 2, 3, 4, 5, 6 ways, so that means C45 is 6. Got it? Okay. Now, of course, things are going to get harder. The positive integer m equals the sum of the positive integers from 4 to n inclusive. Determine the values of a and b with a less than b, for which m is equal to 1/2 n plus a times n plus b for each positive integer n greater than or equal to 4. So if you recall, some of you definitely know this formula, that if you add consecutive integers from 1 to n, it can be written as n times n plus 1 over 2. It's a nice formula. But they're asking for the sum of positive integers from 4 to n. So they just want to do this guy from 4 to n. Okay, no problem. Just keep that 4 all the way to n. We'll keep this on this side. And then this 1, 2, 3 we'll bring over here. So minus 6. That's all that is. You got it? And they're saying that that is equal to m. So this is equal to m. Okay? Okay, so then they tell you that m is equal to that guy. So we have n times n plus 1 over 2 minus 6 is equal to m, which they're saying is 1/2 times n plus a times n plus b. Okay? So they want you to eventually figure out what is a and what is b. Okay? So let's see here. First thing I'm going to do is get rid of these halves. So if I do that, if I get rid of the half here, this is just going to be n times n plus 1, and this will be minus 12. And this will be, well, that side doesn't change for now. And then I can get rid of the halves, and then let's expand this. So n squared plus n minus 12 is n plus a times n plus b. And I think at this point I can factor one side, this side here. So this doesn't change. That'll just be n plus a, n plus b. When I factor, I have n, 3 and 4? And then I have to figure out what are the symbols. Plus, minus, I believe. Yeah. Let me think about this. Hold on. Yeah, plus, minus. So that means if I just do a comparison, a is minus 3 and b is 4, right? Because there's a is less than b. That's why I can make that conclusion. And I think that's it. That pretty much solves part B. Determine the value of C2 to the times 3 to the power of 4 times 5 to the power of 6. Okay. So they have given you this big long number, and they want you to do the same thing, but obviously you're not going to do it manually. It would be way too time consuming. So let's see what we can do. One way, basically, of figuring out is you are essentially adding consecutive numbers, right? X plus 1, plus x plus 2, plus x plus 3, and so on, all the way up to a certain n. And if that can be done, then that is one possible way of figuring this out. And then you have to figure out how many different ways. So if we take this, just this, it would be 1 plus 2 plus 3 all the way up till n is n times n plus 1 over 2. And then all the x's, how many x's are there? There's going to be, I believe, n plus 1 x's. So n plus 1 times the x. There's going to be that many x's. So this we can factor n plus 1. And when we do, we get n over 2 plus x, right? Yeah, n over 2 plus x. I think that's, and if we can continue to sort of, let's see here, if I add the fraction, it'll be n plus 2x over 2, like that. And that is one way of writing this big long number. So there's many, well, that's sort of the general way of writing that big long number. And yeah. And then if you just put the half out front here, just to make it a little cleaner. So basically what that means is that this number, or any number, can be written in this form where you have the product of two numbers, since x is a number and n is a number. Got it? So basically what we have sort of seen by doing this is that the problem of evaluating this guy is really appears to be the equivalent of counting the number of ways of creating these kind of factors, the number of factor pairs. So I'll just write that out. Write out what I just said. So just to repeat, this problem of evaluating CM appears to be equivalent to counting the number of factor pairs of M, in particular n plus 1, which is this guy, and n plus 2x, which is that guy. And in particular, you'll find out that it's actually just the odd factors. So before we tackle this big guy, let's look at the first question, which was C45. Now we had figured out that that's 6, right? But let's see if we can do it in this way. What is 45? Well, 45, I believe, is 9 times 5? Yeah, 9 times 5. So, and that's 3 to the power of 2 times 5 to the power of 1. So we have to figure out the number of factor pairs. And there's a trick, right? You guys remember, you take this first exponent and you add 1. And then you multiply by taking that exponent and adding 1. And when you do, you get 3 times 2 in this case, which is 6. That's how you figure out the number of factor pairs. The number of, I guess, ways of writing 45 as a product of two numbers, right? And that matches. So you do the exact same thing over here. So this time, and remember, you're concentrating on odd factors, so you're only looking at 3 to the power of 4 and 5 to the power of 6. So same thing, you take this first exponent, add 1, and then take the second exponent, add 1, and that's 5 times 7, which is 35. So that is basically the answer to this question, 35. And that is basically the answer to this. Determine the smallest positive integer k for which ck is 215. So this time they're working in reverse. They're giving you the value and they want you to figure out the k inside. Okay, well ck is 215. 215 is what? 5 times 43. Now remember, k, if we write it in terms of our primes, it'll be 2 to the power of something. The first prime to the power of something, some exponent. The second prime times some exponent, and so on. And based on what we discovered in the previous part, our ck would basically just be this exponent plus 1 times this exponent plus 1, and so on. That's how you'd it's basically the number of factor pairs. So they've already given you that this is 5 times 43. Now we want the smallest. The key thing is we want the smallest. So the only way we can do that is by limiting our primes to 2. We'll just use 2 primes. And I'm going to make it the smallest possible, I will choose a equal to 0 so that this disappears and we don't count that anymore. And we'll just match these guys. So this 5 is this, so that means E1 is 4. And this 43 is this, so that means E2 is 42. And then we still have to choose these primes, though. So I'm going to choose the 2 smallest primes, other than 2, which are 3 and 5. And then I will arrange them so that they can make this as small as possible. So this will be 2 to the power of 0. I'm going to put the 5 here, and put the 4 there, and put the 3 there, and the 42 there. And that simplifies to just 5 to the power of 4 times 3 to the power of 42. And that would be the smallest k for which ck is 215.